Hi everybody, thank you for inviting me today. I'm happy to present one of the solutions we've been working on at Gens, namely an on-farm bioreactor that allows farmers to produce their own fertilizers at a farm scale, and in doing so be more profitable and environmentally friendly. But first, let's meet one of our farmers. Meet farmer Janus. Janus has some challenges. Year after year, he is noticing that he needs to put on more fertilizers, needs more diesel for his tractor, and oftentimes also more pesticides to grow the same amount of crops. Now, obviously, that is reducing his profits because he's not earning more, he's spending more. Now, this is quite scary for him. He feels locked into the current system. He sees his farm profitability going downwards, and he doesn't see a way out in the current system. Now, when we zoom out, Janus doesn't appear to be alone, right? Fertilizer use is a major contributor to the overloading of the biogeochemical flows, one of our key planetary boundaries. Not only the biogeochemical flows, we also see influences on pesticides, biosphere integrity, etc. So it seems like fertilizers are one of the key causes of environmental degradation, which is something we already knew, right? Looking into the scientific picture, we find some of the root causes of this issue. We find very low nutrient use efficiency of many common fertilizers, especially the macronutrients, between 15 to 60% only. That means that farmers are paying a lot of money for nutrients that are not ending up in the plant, but ending up in our soils, in the rivers, in the sea. Also, there's increasing evidence that long-term fertilizer use, mainly synthetic fertilizers, are contributing to the decline in natural soil fertility, up to 50%. This can be due to collapse of soil structure, shifting of soil microbiology, binding of certain nutrients, right? There's a whole range of underlying causes there. And nutrients are not only leaving the system via the soil, but also through the air. Many nutrients volatilize, end up as greenhouse gases in the atmosphere, and combined with the fossil fuels used to produce fertilizers, that has a significant impact on global greenhouse gas emissions. That was the reason for us to find a different solution. Now, this is our prototype bioreactor, and this allows a farmer to produce a number of fertilizers on their farm. First and foremost, microbial inoculants. Many soils in agriculture are depleted of the soil microbiome, and farmers can actually produce their own microbial inoculants fairly easily. Just need the right tools. This bioreactor is one of them. These microbial inoculants can be used for seed coatings, they can be injected into the soil while planting, or they can be combined with other fertilizers and sprayed on the leaf of the plant, so that some of these microbes can also start inhabiting the plant itself. Second category are organically chelated plant nutrients. That's a mouthful, right? So these are nutrients that have an organic coating around them. And that coating prevents these nutrients from being uptaken too rapidly in the soil. It becomes a slow release fertilizer. And the benefit of it being an organic chelate is that this can break down naturally in the soil. It often is food for the plant even, or stimulates soil microbiology. Now, this can increase nutrient use efficiency incredibly. So, for example, for foliar fertilizers, we can see nutrient use efficiency up to 90% or more. And the last category are amino acid biofertilizers. Now, these are fertilizers that can directly substitute nitrogen fertilizers. Instead of adding nitrogen in the form of urea, nitrate, or ammonia, that the plant then has to still convert first into amino acids and then into protein, we can do what's called metabolic shortcutting and directly apply amino acids. Saves more energy for the plant, it's a biological component, and is quite cost effective to produce yourself on farm. Now, what is underlying this cost effectiveness is that we're aiming to use local resources to produce these fertilizers. They can be leftover material from processing of food, can be cover crops, it can be seeds that a farmer might have planted, companion crops, for example, that have been harvested together. Wood is oftentimes a good biomass, manure, etc. There's many resources locally available to a farmer that can be used to produce these fertilizers. Now, what are some of the potential benefits? In our preliminary trials and some of the studies that we've done, we can see fertilizer reduction up to 20 to 70%. Now, to note these benefits, they are possible in the first year, but often they require a bit of time, 3 to 5 years to reach the full potential. Profitability per hectare, or cost savings rather, between 185 to 380. A lot of this profitability comes from farmers who are over-applying certain nutrients. And by increasing nutrient use efficiency, that is a way to reduce the cost so significantly. And then a reduction into greenhouse gas emissions, because these compounds are much more stable, they don't require fossil fuels to produce, we have a much lower footprint with them. Now, looking at some of our research trials, we can see some core issues that we often encounter. So severe soil compaction is one that we see in many soils that have been fertilized for a long time, and a lack of a nutrient cycle is another one. Now, in one of our trials, we saw really incredible results after 2 years with using some of these products. So in this trial, we did all 3 of them. We used microbial inoculants, the chelated trace minerals, and we used amino acid fertilizers. So what we saw after 2 years' time was an incredible improvement in soil structure, enhanced nutrient cycling. In the first slide that I showed you with the compaction, there was no soil life. In this soil core that we dug up, we found 52 earthworms, which is a key indicator that we can see for nutrient cycling. Also found increased kernel weight, and for this farmer, reduced fertilizer costs of 20% after these 2 years. And you can see clearly, this was the control field next to it, this was a trial field. Soil structure really significantly differs. Now, this solution is still in development. We're working together with farmers locally and internationally, mainly in Estonia and Finland, but we're happy to see some promising early results and hope to continue working together with farmers. Happy to take some questions.
So there is one question right now. Can you use digestate from biogas production as raw material for your bioreactor?
Yes, this is definitely possible. So digestate is when it comes out of a biogas facility, oftentimes still has many undigested compounds and is oftentimes unstable. It also has a microbiome that is not necessarily suitable for a soil. In the fermentation process, you can have a lot of alcohols and other substances. So by using the digestate in our bioreactor and fermenting it with a nutrient consortium, or rather a microbiology consortium that is more suited to the soil, you can stabilize the nutrients and you can have a benefit. So oftentimes digestate that is now applied to the field leaches a lot of nutrients, and in this way you can stabilize it.
So you showed us slides with already work in process. You have some experience from that, but still in this slide where this reactor was described, there was a Saigon prototype.
Yes.
How far away are you from mass production?
So we're still quite a bit away from mass production. We have the first 2 prototypes that I showed you. We've worked with earlier prototypes that were more rudimentary. This prototype is now made out of stainless steel, much more durable, and has more functionality. That should be delivered, hopefully, next week. So it's produced, but still underway.
And what is your business plan? Do you want to be producer yourself, or you try to sell it like a possibility to build up them from for others?
So the idea is to empower farmers to produce their own nutrients. So in the beginning, if farmers want to try these products before you want to buy the bioreactor, we have some products that they can trial and they can see the results of it. And then when they're ready to buy their own bioreactor, they can buy the bioreactor themselves. One of the next steps in our prototype, this is why it's still a prototype, is to automate this process. Right now, it still requires a bit of manual labor, but the goal is to make sure that it's almost like a bread machine. You enter the ingredients, you push a button for a certain recipe, and it makes it for you. That's the ultimate goal.
Oliver, fingers crossed. Thank you.
Thank you so much.
Yeah.